Welcome back. So in the last video we spoke about the projectile motion, just some of the properties of projectile motion. Now I want to have a look at the sample problem and just look at how I would start the problem. The actual calculations are already in the notes, so I just want to have a look at how I'd go about writing down the SUVAT for those. So we have consider an object projected horizontally at 35 meters per second from the top of a 125-meter cliff overlooking the sea. What is the object's horizontal range? So that's displacement. How far out from the base of the cliff does the object hit the sea? So what we do is we can first of all define that which way is positive. So I'd say that's positive because that's the direction of the horizontal motion, and would say that downwards is also positive. Makes it a little bit easier. So then we can write down HOR for horizontal, and then we write down SUVAT. So we're looking for the range. U is equal to 35.0 meters per second. Velocity is 35 meters per second. Acceleration, we don't know. And time, acceleration, sorry, we do know, it's 0 meters per second. And time is the one we don't know. Okay, so we write down horizontally exactly that, and that's all we know. So vertically, what else do we know? So we know that S is equal to 125 meters downwards. U is equal to 0 meters per second. V is unknown. A is equal to 9.81 meters per second squared. And this was a squared over here too, I always forget that. And time, if we don't know the time in the horizontal, we don't know in the vertical, and vice versa. So the useful thing about projectile motion is once we work out the time for one side, we can work it out for the other. So in this case, we could work out the time in the vertical, so how long does it take to drop, and then we can use that time in the horizontal to work out its displacement. And that's the method, that's the kind of approach that we take. Okay, and that's all we need to do for this one. And if you follow through then in the answers, they start off with the vertical motion, and they find the time here. Okay, so they use S equals UT plus a half AT squared. And then they find the time. Okay, so then they're able to use the time for the horizontal motion as well. And they use the same formula, S equals UT plus half AT squared, and they find out that the displacement, or the range, is 177 meters. Okay, so that's just one of those simple problems. Alright, in this, we'll do the next example in another video.